Hi everyone, you've heard me say this before, and I'm probably going to say it again, but this is one of the coolest setups we've done so far with the ShotoLab system. It consists of a continuous process used to make a chemical intermediate. We are using a continuous stirred reactor, a liquid-liquid extraction column, 3 continuous distillation columns, fractional distillation columns, followed by a simple distillation. Now, since this is a continuous process, it takes 9 Masterflex pumps to run this whole system. But the unique thing about these pumps is they are actually controlled by the ShotoLab system using our Anapod adapter. Now, this looks complicated, and truthfully it is a little bit, but it didn't start that way. To start this process, we first developed the reaction phase of the process and then proceeded with the distillation phase of the process. To do this, we started with 2 ShotoLab power supplies, a Shoto Power 2 and a Shoto Power 3. First thing I did was connected the pins for the heat controllers, the 5 pins for the heat controllers. Then I plugged in the heating mantle for the reaction and the 4 heat tapes for the columns. Then I plugged in the terminals for the Anapod controllers for 4 of the Masterflex pumps. Next, I added the Shoto boards. The bottom terminal strips connects the control pins for the heaters. The top terminal strip is for the Anapod controllers, which are running the Masterflex pumps. The middle strip is for the thermocouples. Now again, this is just the thermocouples for the reaction phase of the process. Now I mentioned that the Masterflex pumps are controlled by the Anapod controllers using the ShotoLab system. This is what the Anapod adapter looks like. It's simply a switch with the connector pin. The switch allows the controller to be used manually as normal or connected to the ShotoLab power supply, and the cable connects to the ShotoLab system. So here's the reaction as it's working. On the left there's just a little small flask that we're using to mix the reagents together. Once they're mixed, they're pumped into the continuously stirred reactor. You can see the side port where I'm taking off product that goes into the liquid-liquid extraction column. It's fed to the top of the column, and you can see that it's slowly trickling down the column, extracting out a catalyst. And to the right you see the effluent stream, one of the effluent streams from the column, and the height of these 2 effluent streams is what determines how this column functions. And then product effluent stream is pumped into the distillation columns. And again, here's what the final system looks like. Let's go over the distillation phase now. And from that initial continuous reaction process development, the system morphed into what you see here. It's a little more complicated with all the pumps. And now let's go over the distillation phase of the process. The effluents from the column are going into the first distillation column. They're being fed in the middle of the column, and you can see some of the distillates coming out. Here's the reboilers of the 3 fractional distillation columns. You can see the thermocouples going into the liquid and vapor phases of each. Bottoms are pumped off as they fill. And I'm just starting up the system, as you can see from the data that's being displayed. Top left is the first distillation column temperatures. The top right is the second distillation column. The third distillation column is on the bottom left, and the simple distillation is on the right. These still haven't come to temperature. Here's some of the reaction parameters. On the top left is the flask where the reagents are being pre-mixed, and you can see that 4 batches have been added from the 4 exotherms depicted. On the top right are the flow settings for all the pumps. On the bottom left is the reaction temperature profile. Here's the distillation columns again. You can see on the bottom left that the third distillation column is coming to temperature right now. And let's see what it looks like in the hood again. You can see the third distillation column is boiling right now. Liquid is going up the top, and that third distillation column is actually a vacuum transition column. There's really not a lot of separation going on there, I don't think. The system is being run under vacuum as the pressure gauge shows. There's also a pressure transducer that's being recorded on the ShotoLab system itself. But again, here's the liquid boiling in the flask, and here you can see the distillation flask is coming to temperature. The temperatures are going up. And if we look at that flask, you see there's a little bit of liquid in it now, boiling. And all of these have takeoffs from the bottoms. Each of the distillation columns has a takeoff on the bottom, as you can see, being pumped out. The columns are fed somewhere in the middle. You can see the distillates coming off, and soon we'll have distillate coming over as a final product. As you can see, the screen is quite busy, which is why we have the monitor mounted on the hood. On that monitor, we can plot the most relevant data for the process and make sure that we can control the process. Here's more data as the reaction was progressing. You can see that the distillations are actually relatively consistent. On the bottom right, there's a lot of variation because of the vacuum. If I would have put in a vacuum buffer, it probably would have ran a little smoother. I hope you got some idea of the power of the ShotoLab system and how it can control complex continuous processes, and hopefully it sparks some ideas on how you can use it in your process development work. Feel free to call if you have any questions or have any comments.